Welcome back to our YouTube channel. Today we are going to discuss the chemistry paper, the Cambridge IGCSE June 2022, and we are going to solve this paper. And without wasting the time, here we are going to start the first question. Let's go. The first is the apparatus shown was used to determine the percentage of oxygen in a sample of air. So here you can see that like the apparatus that is shown here. The glass tube was heated strongly at X here, while the sample of air was passed backward and forward over the copper piece in a tube. Okay. The source of heat was gradually moved along the tube from X to Y. During the experiment, the copper pieces in the glass tube react with the oxygen in the sample of air. Name the item of apparatus labeled as B. So here is B. So it means that apparatus is syringe. Okay. Or you have to write gas syringe. Okay. Now name the item of the laboratory equipment that could be used to heat the glass tube strongly. So here you know that for heating purpose we use Bunsen burner. Bunsen burner. Okay. Now the third, the copper piece at Y did not change color when they were heated. Suggest why the copper piece at Y did not change the color. Here in the information we discussed that the copper pieces in the glass tube react with oxygen in the sample of air. So it means that when all oxygen used are consumed up, so it means that the copper does not react. So here the answer is all oxygen used up. Okay. Now the next question. Here is the table show the volume of air in each part of the apparatus at the start of the experiment. Here is like the table that is given. Calculate the total volume of air in the apparatus at the start of the experiment. So glass tube volume of air is 8 and the B that is 94. So 8 plus 94 is 102. Okay. Now the next, here the table shows the volume of gas in each part of the apparatus at the end of the experiment. Here the glass tube is 8 and the B is 75. Calculate the percentage of oxygen in sample of air. So here we need to find the percentage of air. So for finding the percentage of air, first as we know that here is the B is 94 and like here the final one B is 75. So 94 minus 75, that is 19, and then here 19 over the total volume of the air, that is 102. So times 100, because we are going to find the percentage, and here the percentage is about 18.6. Okay. Now here is the question number 2. A student investigated the reaction between aqueous sodium hydroxide and two different solutions of dilute hydrochloric acid with different concentration, labeled Q and R, using two different indicators. So here are the three experiments. In the first experiment, use the burette diagram to complete the table for experiment 1. So final burette reading. So here is the final burette reading, that is 20.3. So here is 20.3 and the initial one, that is 2.7. Okay, and here like the difference between the volume of dilute hydrochloric acid that is used, so here is 17.6. Okay, next here, that the final burette reading that is 43.7, and the initial one 8.5, and the difference is 35.2. Okay, now the next here, in the third experiment the final reading is 42.2 and the initial is 7 or 7.0 and the difference is 35.2. Okay, now number B, that is experiment determine the simplest whole number ratio of the volume of dilute HCl are used in the experiment. So here the experiment that is, you can see here like HCl and NaOH. So you know that as like the equation HCl plus NaOH that gives NaCl plus water. So as you know that HCl and NaOH, the simplest whole number ratio that is 1:1. So here you have to write 1:1. Okay, now next is deduce the volume of dilute hydrochloric acid Q needed when experiment 1 is represented using thymophenolphthalein indicator instead of methyl orange indicator. So we already did, that is how much, the final volume that is 17.6. Here is 17.6. okay, and that should be in the centimeter cube. And next question is about compare the concentration of dilute hydrochloric acid Q used in experiment 1 to the concentration of dilute hydrochloric acid R used in the experiment 2. So you can see here that in the experiment 2 that is 35.2 and volume of dilute hydrochloric acid Q that is 17.6. So dilution means that 35.2, it means that is more diluted, R is more diluted. So it means here you have to write that Q is more concentrated than R. Concentrated than R. Okay, the first one. And the second one, because here is the 3 marks question, so you have to write the next point, that is as smaller volume of Q is required here, that because that is more concentrated, so that's why there is like less volume of Q that is required, 17.6. so here the second one, that is as smaller volume of Q is required. Okay, and the third point you have to write here, like you can see as R is twice than Q, so it means that R is more diluted than Q, or you have to write that the volume of Q is half the volume of R. So volume of Q is half than R. Okay. Now the next question is state how the result change if at all if the aqueous sodium hydroxide is warm before the adding the dilute hydrochloric acid. Give a reason for your answer. So first of all, here the result will be none because that is not effect. So here is none, and the reason is because you know that it does not change the amount like concentration or molar or moles of sodium hydroxide. Okay, like when we warm the sodium hydroxide solution, but it does not affect the overall because it does not affect the concentration, it does not affect the moles, or it does not affect the like amount of sodium hydroxide. So here is does not affect, and I told you the three reasons like moles, concentration, or amount of sodium hydroxide. Next question is state the advantage of using a pipette instead of measuring cylinder in these experiment. So you know that for measurements like for more accurate measurement, so here is you have to write for the reason is accurate measurement. Okay, and the next one, explain why a white tile is used in these experiment. Because for the reason is the color change that can be seen easily, because here we use the indicator, and when we use the white tile in these experiments, so color change will or can be seen easily. Okay, next question, at the start of the experiment the burette was rinsed with the distilled water and then it was diluted with the hydrochloric acid. State what was removed from the burette when it was rinsed with the distilled water. So you know that here that is because we are going to start the second experiment, so we need to remove Q. Okay, like the previous HCl. And now the next one, that state what was the removed from the burette when it was rinsed with the dilute hydrochloric acid R. So here that is we have to remove from here water. Okay, and the next, explain why the burette does not need to be rinsed at the start of the experiment 3 because of the same acid used. Okay, next question, after the burette was filled with the dilute HCl at the start of the experiment 1, some of the acid was run out of the burette. One reason of the running of acid out of the burette is to make sure the level of HCl is on the scale. Give one other reason why it is important to run some acid out of the burette after it has been filled with for the first time in an experiment. So here you have to write the other reason is like to fill the part of the burette below tap, or you have to write that to fill all of the burette. Okay, to fill all of the burette. Question number 3 is about like solid S and solution Y were analyzed. S was copper sulfate, and here complete the expected observation of flame test was carried out on the solid S. So you know that contain copper, so it means that show blue green flame. Okay, the remaining S was dissolved in the about 10 cm of distilled water to form solution T. Solution T was divided into two approximately equal portions in the two test tubes. State the color of the change that occurred when the water was added to solid S. So initially the color of the solid is white, copper sulfate, but when it is in the dilute form, it will show blue solution. Okay, next question is, to the first portion of the solution T, about 1 cm depth of the dilute nitric acid followed by the few drops of aqueous barium nitrate were added. So what will be the observation? So here when we use the barium nitrate, here in the presence of dilute and HNO3, the nitric acid, so it will show white precipitate. Okay, white precipitate. And the next question is, to the second portion of the solution T, aqueous ammonia, here is the ammonia is used instead of like barium nitrate, and then in the excess, so here the first observation, because here is the 3 marks question, so it means you have to write at least 3 observations. So the first one is, it will not form a white precipitate, it is not present as a precipitate form, that is now dissolved like solution form. And what type of solution? The color is like light pale or blue. Okay, and like when we use excess, so it will change into deeper blue. Alright, next question is, here are the some tests and the observations. A flame test was carried out on solution Y. The flame become lilac. So you know that the potassium, that is indicate the lilac color. And here the next one, the dilute acid was added. The portion of solution Y in a boiling tube, the mixture was warmed. A strip of filter paper soaked in the acidified aqueous potassium manganate and like potassium permanganate was held at the mouth of the boiling tube. The observation is the acidified aqueous potassium permanganate remained purple. So that is the indication of iodine or iodide ions. Okay, and now the next, here about 1 cm depth of dilute nitric acid followed by, okay, here I'm going to write like the questions, like name the gas tested for in the test 2. Here in the test 2, that is, okay, you can see here again like dilute HCl was added. So here that is sulfur dioxide, that is the gas, that is the tested in the in test 2, and identified the 3 ions in the solution Y, and the 3 ions are here as we already discussed. The first is potassium, the second one is iodide. Here I'm going to write potassium, iodide, and the third one you can see here like yellow precipitate, solution Y, and then aqueous ammonia was added dropwise, and then in the excess of third portion of solution Y, a white precipitate formed when it dissolved in the excess to give a colorless solution. So here that is the indication of zinc. Okay, or zinc ions. So you have to remember how, like here whenever you have to write, that should be in the ionic form. Okay, potassium ion, iodide ion, and zinc ions. Now here is the question number 4. I think that's the last question. And here is, when solution A and solution B are mixed, they react slowly to form iodine. Starch solution is added to the mixture to act as an indicator. When a certain amount of iodine is made, there is a sudden color change to blue-black. Plan an investigation to find the effect of temperature on the rate of the reaction between solution A and solution B. You are provided with the solution A, solution B, starch solution, and common laboratory apparatus. So here is actually that is the 6 marks question. So you need to write at least 6 points for this question, okay, in the answer. So the first, you have to take the known volumes of A and solution B, like known volumes of solution A and B. Okay, the second one here is like you have to measure the temperature and suitable apparatus for measuring volume of solution. Suitable apparatus for measuring, and the next you have to measure the temperature. Okay, and here the next is you have to mix the solution together with starch solution. Next is mix the solution, and the next point you have to write that you have to wait until blue black color seen. Until blue black color appear or seen. Okay, and here I think these are the 5 points, and here I'm going to write more. Okay, now repeat at different temperature. Okay, and the solutions should be warm before they mixed. Okay, so these are the points you have to write in this question. So here is the end of this paper. If you like our video, then kindly subscribe our channel, and in the next video we will discuss some other papers too. So take care. We'll see you in the next video.